Migrate from CPROTEC 4 to CPROTEC 5 in 12 steps.
Before we start, some explanation. DIGSI plugin is a support tool which enables device settings in a convenient manner. The data format TIAX, Totally Integrated Energy Automation Exchange, is used for data transfer for import and export between DIGSI 5 and Excel. With the support of the Retrofit device selector, we selected the new CPROTEC 5 device. With the DIGSI 5 configurator, we create the order number. Then, with DIGSI 4, we prepare the information of the device configuration. We analyze the device characteristics. Based on the result, we configure the new 7SX85. With the Excel plugin, we edit the settings. Then we do the CFC adjustments, make modifications in display pages, editing the signal routing, make protocol communication mapping. Final works, we do some final work, for example, setting of the time synchronization. And we make pre-testing with digital twin to be ready for commissioning.
The Siemens Easy Protection Selection tool for retrofits help us to find the devices that can fit best a successor of the current existing device, either from Siemens or other manufacturers. In our example, we select Siemens as manufacturing company and type 7SJ64 in the box for the product code. As a result, we get the CPROTEC 7SJ85 and 7SJ82 recommended.
In the next step, we can make use of the CPROTEC 5 configurator to define the specific hardware to be used and the required amount of function points. Remember to include all the functionality you are looking for with the migration. And also check if you want to take advantage of new features which are useful and can be easily added in the device, such as circuit breaker monitoring, power quality, or automatic voltage regulation, just to mention some. With the CPROTEC 5 devices, you have two options when it comes to functionality. First, you can calculate the required functions point with the function points calculator and order the device with the defined amount of function points. Or you select the classless option and download from the online function point manager at a later stage the exact amount of function points given by the configuration in DIGSI.
In the next step, we will prepare the configuration information of the 7SG641. To do this, we open the device with Open Project. And then we export and select configuration and protection parameters. Then we select CSV file and store it. As a result, we get a corresponding CSV file. This CSV file can be converted to an Excel file for further viewing. Migration step 4, analyzing of the 7SG641 configuration. We open the converted file. The following information from the Excel file is of interest for the CPROTEC 5 configuration in DIGSI 5. This is a device configuration, the masking I/O of binary inputs, binary outputs, and LEDs. The masking I/O interface for IEC 60870-5-103 protocol, source and destination. The power system data 1, which contains the CD and VD ratio and CD and VD connection properties. The setting group A, which contains the setting parameters of the function activated in the 7SG641 device. Migration Step 5, configuration of an adequate device. The data exchange format TX was developed to make the parameter input of DIGSI clearer and more manageable. This assumes that the new Seprotect device has the same functional properties. At the beginning in DIGSI, we add a new device. We insert the long product code. Application templates contains the basic configurations, required functions and default settings. The templates provide only an absolute basic device configuration, which is not suitable for an application. They serve only as a starting point for a specific application configuration. For our purpose, we select the application template universal for current, for voltage. After the device generation, under settings we adapt the functional structure to the primary components of the 20 kV outgoing field. The pre-configured function group type voltage current 3-phase is suitable for use in our 20 kV bay. In the voltage current phase protection group you can use all the functions for protection and supervision of a protected object or equipment that allows 3-phase current and voltage measurement. The function group also contains the operational measurement for the protected object or equipment. Next, we check whether the protection functions embedded in the function group meet our requirements. Superfluous function can be removed and missing functions can be added from the global library. In our case, the directional overcurrent functions 67 and 67 neutral can be deleted, which saves function points. The missing function overvoltage protection are added from the DIGSI global library via drag and drop. Next, we look at the circuit breaker function group. We must add the missing function trip supervision with 2 binary inputs from the global function library. The pre-configured disconnector 1 and 2 are controllable 1. In our case, we need only the status information. Therefore, we exchange it with the switching device's disconnector status only. For a better understanding, we rename the name of the circuit breaker and switching devices. Circuit breaker 1, in circuit breaker Q0, disconnector status 1, in switch track Q1, and disconnector status 2 in earthing switch Q8. With a change of switching devices from controllable to status 1, we must adjust the pre-configured interlocking conditions. The switch track Q1 and earthing switch Q8 are not controllable. We can delete the logic blocks for their interlocking conditions. And for the circuit breaker, we make a new signal connection. Now we have prepared the 7SX85 protection device so that the range of function corresponds to that of the 7SG641 device. Migration Step 6, setting data transfer with support of the DIGSI data exchange format and DIGSI Excel plugin. Before we export the DIGSI file of the 7SX85, some values must be set in advance. In the Power System group, under Measuring Point Current, the rated primary current. In Measuring Point Voltage, the rated primary voltage. In the protection group, voltage current 3-phase, under general, the object rated current and rated voltage. In the circuit breaker group, under general, the reference for percent values. After doing this, we are ready to export the DIGSI file. Select Export Setting Values Secondary and press Export. This file will be imported in the DIGSI 5 Excel plugin. Therefore, we open an empty Excel file, select DIGSI 5, press Import from DIGSI file, and select our DIGSI file. Here you can see the clear representation of the setting parameters. The values can be set in the yellow cells of column L. As base for the setting value, we can use the exported parameters from the 7SG641. See Migration Step 3. The setting takeover of the normal overcurrent function should not be a problem, but protection setting should be handled very carefully. Due to technical progress and the further development of the protection algorithm, some of the setting values can no longer take over directly. Therefore, Siemens recommends observing the protective function and the setting instruction in the manuals. After you have finished the parameter setting, you can export the edited file with the export to DIGSI. And import this file in your DIGSI 5 project. Migration Step 7. Automation and adjustment of CFC. Each application template generates at least the following 3 CFC charts. The CFC chart group warning belongs to the alarm handling of the CPROTEC 5 device. The signals are pre-configured based on the application template. After every change in the function groups, you should check this chart. The CFC chart interlocking contains the pre-configured basic interlocking conditions of the circuit breaker and switching devices. The chart can be easily adjusted to the required interlocking conditions. The CFC chart process mode inactive is also part of the warning and alarm handling of the device and should be not changed or deleted. DIGSI 4 CFC charts can be converted to 65 using the export and import function. Please note that the CFC in DIGSI 5 is significantly more powerful and not 100% compatible with the CFC in DIGSI 4. Migration Step 8: Modification of display pages. The pre-configured display page does not match the primary base signal line because in the 8BK20 switchgear bay, the line earthing will not be realized with the circuit breaker on position, but directly on the cable. So we recommend using an adequate display page, like the following example. The device display pages can be imported and exported with the star.dsp5 file format. Migration Step 9: Signal routing. Finalize the signal routing of binary inputs, binary outputs and LEDs with the information routing editor. We recommend connecting the trip command to a fast relay. The information of the binary outputs, contacts, fast or standard, you can get via selecting hardware and protocols. Migration Step 10: Communication Protocol Mapping. At first we assign the protocol ESC 60870-5-103 to the installed communication module. Then under Mapping we select the universal for E for V. Then you open Communication Mapping and select EEC 6870-5-103 protocol. With the Communication Mapping Editor, you can adjust the pre-configured mapping. Migration Step 11: Final Works. To finalize the configuration, you must do some additional works. These can be the setting of the time synchronization, the setting of the response thresholds when using the trip circuit supervision function, and so on. One more point is worth mentioning: checking the actual function point consumption to save costs. Migration Step 12. Siemens recommends using the ZProtect digital twin for pretest of the device function to reduce the commissioning time.